Today we're going to look at relations and functions, and some of this may be review and it may look familiar to you because it was probably taught in math too. But some of it I'm going to add to or maybe show in a different way, so you really should pay attention to the information. On the first couple of slides we have definitions, so after I go over the page I'll ask you to pause the video, copy the definitions as you're taking your notes. So what is a relation? Well, it's a set of ordered pairs. Now, and that's a very simplified definition of a relation. It really shows how X and Y are related to each other, and what values of X have what values of Y that goes with it. So they can be written as many different ways. And so there are 5 types of relations. You can write a set, which is really points, the coordinate pairs for the points. Now those points could be in a table, the points could be on a graph, mapping, or we could just have an equation where we could calculate infinite number of points. Today our focus is going to be on the first 4. Equations is going to be a separate lesson. The domain of a relation is a set of x's from the relation in increasing order and do not repeat the values, and that is very important. They must be increasing and they must not have repeats in them. So if you have 2 x's that are 4, you don't put 4 twice, you just list it once. Same thing for the range. It's a set of y's from the relation in the increasing order and do not repeat values is still important, because when you're showing somebody the domain of range, you just want them to be able to see what values does this relation cover. Now relations don't cover every point there could possibly be. It's a sampling, except for equation. Equation covers them all. But these other 4 only cover a small set of points that relate the domain and range. So you should stop the video now and copy these definitions, and then when you finish copying it, start the video again for the next page of definitions. So on our next page of definitions, the inverse relation, that's a very new topic that we're going to talk about. To inverse a relation, it's a set of values in which the x and the y coordinates of each point have switched. So it's very simple to switch an x and a y value. It's nothing really complicated. And then our other definition is we're going to talk about functions. There are a set of values in which each x coordinate only has one y coordinate goes with it. An example of this would be if you put 2 in for x, you might get 3 out for y. Now, if I get 3 for y and Sue gets 7 for y, one of us is wrong, because there can only be one right answer to a math problem when you are evaluating. So that's why please excuse my dear Aunt Sally is so important. Putting parentheses around negatives and fractions is so important, because there's only one right answer. And it's a function if you get only one right answer. If you get 2 y values, it's not a function. So now we're going to look at questions that go with this. And wait a minute, let me go back a minute. So you need to copy these 2 definitions down, and then once you have, start the video again, and that will allow you time to copy them before we start doing examples. So as we start looking at examples of these problem sets, let's see what we have here. For each relation, state the domain and range. Is the relation itself a function? Make the inverse relation. State the domain and range of the inverse. Is the inverse relation a function? So what does it mean to state the domain? Well, it means to put the x's in order. So I got -2, -1, 0, 1, 1. See how there are 2 1s? So we only list it in order and only once. And the y's we have 1, 4, 7, 2, 10. So the 2 is in the wrong place. 1, 2, 4, 7, and 10. It's okay that the range has more values than the domain, because that shows something about the relation. So is the relation a function? When I look at those x's, each x can only have one y value, and the y values, those x values over here, with 1 is 2 and 1 is 10, one can't be both. So no, this is not a function because the x is repeated. So the x's can't repeat and be a function. So now let's talk about the inverse relation. The inverse relation is a set of points in which you switch the x and the y values. Whoop. Forgot to switch it. So now what we're going to do is we're going to state our domain, and as we state our domain, we're looking for the x's. So we've got 1, 2, 4, 7, 10 in order. And then over here for your range, you've got -2, -1, 0, and 1. Now you'll notice that that's just right the opposite of the domain and range for the original problem. And that's what it does. It switches the x's and y's. So if I ask you to give me the range of an inverse, you just have to make the domain of the original, because it's the same thing. Or vice versa. If I ask you to find the domain of the inverse, you just need to make the range of the original and it'll become the domain. So now when we look at our new x's, they don't repeat. And so therefore the inverse is a function because the x's don't repeat. Also, you don't have to make the inverse to figure that out. It's just a well-known fact that if a relation doesn't repeat the x's, it's a function. And if the y's don't repeat, it has an inverse function. And so that's something you might want to write down as a rule. If your x's don't repeat, then the original problem is a function. If your y's don't repeat, then your inverse is a function. And that would save time on making a lot of things to check that out. Let's try another one. In our next example, we have a table. Now, a table's kind of organized. A lot of times, the x's have to be in order. So that's good because then it makes it really easy to set up your domain because it is in order. But your range may not be in order. It has to be increasing. So that means I have to start with a -2, and you can only list them once, which in this case, none of them was listed more than once. Do the x's repeat? No. Wait a minute, excuse me. No, the x's don't repeat, so yes, it's a function. And then we can make the inverse. We just have to reverse our table. So everything on the bottom row needs to come up and be put in order. And then the top row, -2 was with 1, 2 was with 0, 6 was with -1, 10 was with -2, and 14 was with -3. The bottom row has to match up, that the point for the x and the y have to go together. You can't just bring that top row down. You've got to match them back up. Then again, if you want the inverse as domain and range, you just switch the x and y. So you can just switch the domain and range of the original, and it becomes the domain and range of the inverse. And last but not least, is the inverse relation a function? And I could have told this from the original problem because the y's don't repeat, or I can tell it from my inverse relation that the y's don't repeat. So yes, the inverse is a function. So now we have looked at table and we have looked at set. So let's look at graph. Pause the video for a moment, copy down this graph. Then after copying the graph, we will go through the answers to these questions. All right, now that you've drawn the graph, let's go through and talk about domain and range. Now, with the graph, you have a couple of choices. Choice number one is you could copy down all the points off the graph, make a little list so that you can put the domain and ranges together. Choice number two is to look at it from a vertical and horizontal point of view. So that's what I thought we'd do. So in a vertical view, you can put a vertical line down on every set of dots. Now, I'm not so sure you want to draw that particular thing on yours, but I'm doing it to illustrate something. And tell what values of x did my vertical lines touch. So it touched -3, -2, -1, 0, 1, 2, and 3. There was something on all of those. Now that is very important to look at also is the relation of function. So let's go ahead and do that part. So each vertical line can only touch one point for each x to have only one answer. And there are two places that this one breaks that. At -1, there are 2 points. And at 2, there are 2 points. And all it takes is one place for it to break that rule. Each vertical line can only touch one point, because that means each x has one unique y value. So this is no. And we used a vertical line test to test that out. Now, this domain becomes the range of our inverse. So I'm going to go ahead and write that down. All right, now that I'm done with the x's, let's focus on our graph in a different direction. So if I look at horizontal lines, then I can find the range. So it looks like there's dots on everything from -2 to +2. -2, -1, 0, 1, and 2. That becomes the domain over here. -2, -1, 0, 1, and 2. And then look at the fact that you can use the horizontal line test to see if each value of the inverse is only going to have one value of, each x only has one y in the inverse. So this definitely breaks it almost on every horizontal line that there are 2 points. So the inverse is not a function. No, because it fails the horizontal line test. Now, to make the inverse relation, let's talk about that. And this is why I had you draw the graph. So you shouldn't have been drawing any of this information I just drew up here. This was just to help you visualize. Now we're really going to draw on our graph. So we're going to start with this point here at -3, 1. You're going to switch your values and go 1, -3, and put an x. Then the next one with -2 has a point at -2, and -2, -2 switched is the same point. Here, same thing. That'll be the same point, because -1, -1 switched around. But we also have -1, 2, so now 2, -1. At 0, it's 0, 1, so it'll be 1, 0. At 1, it's -1, so -1, 1. At 2, it's 2, 0, so it'll be 0, 2. And it's 2, 2, so that'll be its own. And then at 3, it's -2, so -2, 3 will be our last point. Now, if you have done this correctly, it will go through the points 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, or -1, -1, -2, -2. It's called a line of symmetry. And what it does is, and this part I wouldn't draw, I'm just drawing this for effect. For example, this makes a right angle here. This makes a right angle here. The distance they are from that dotted line is exactly identical. So it just reflected over the line of symmetry, which is y equals x. All functions reflect over the line y equals x. So they make that 45-degree angle between quadrant 1 and 3, or sometimes they reflect over y equals negative x in quadrant 2 and 4. And so it's real easy to plot that line because you just go through 1, 1, 2, 2, 3, 3, negative 1, negative 1, negative 2, negative 2, and so on. So that's how you make an inverse relation. You just look up the point and switch it. So some students find it very quick to make the list of points because it'll make it easier to stake the domain and range, and it'll make it easier to switch the points and replot them. Now notice that I didn't make a separate graph of that. I plotted them on the same graph. When you make a table, you make a totally separate table. When you make a set, you make a totally separate set. But with graph, you do it on the same graph. So the last one is a mapping. I'm pretty sure you studied this in Math 1 or 2. A mapping shows input and output. Input is x's because you put x's in a formula. Output is y's because that's what f of x equals. And your domain and range is really easy since they're in the input and output because they're already set up and they're already in order. And there are no repeaters in there to worry about. They're just ready to go. Now, that means to find out if their original problem is a function, you want to look at the inputs. Negative 1 only has one answer, but 0 has two answers. 0 can't have two answers, so no. 2 arrows from an x equals 0. All right, let's make the inverse relation. First, let's make the domain and range. That's easy because you just switch the original domain and range. Now, I don't have to make the inverse relation to know if the inverse has a function. I can just look at the outputs. Negative 2 only has one answer. 0 again has two answers. So no, it's not a function. But to make my inverse relation, I switch the x's and the y's. Negative 2, 0, 3. Now let me try that again. And I'll retrace what the outputs went with. So negative 2 went with 0. So I'll point negative 2 to 0. 0 went to negative 1 and positive 1. And 3 went to 0. And if you do this, this is a mirror image of what it originally was. But the arrows still point to the right because you always point from input to output. I wrote outside. Well, I must really be tired this morning. Output. So from input to output, your arrows always point to the output, but you switch your x's and y's. So it's not hard to make an inverse relation in mapping notation. So this is the type of question that is a function, always a function originally, but may not be a function. Well, let me rephrase that. Maybe not always a function originally. Depends on what they write. The domain and range for this are totally different. You cannot list numbers. It doesn't work that way. So we're going to make this kind of a question into a separate lesson for 2.5 because we're going to have to learn how to write domain and range with a different kind of notation. And actually there are two kinds, and we're going to focus on one specific kind in this lesson. And then later in the semester we'll learn the other one. So now you can work on your worksheet and be able to find the answers for the set, table, mapping, and graphs.